Hey guys, we're recording a new video today. Just recently I got Visual Studio Code, so we're gonna open that up. Open my folder. Where is it? Wrong one. VS Code folder. So we're gonna open that up. And what we're actually doing today is more of these generators. Okay, yeah, that command line thing just keeps popping up, interfering with everything. Anyways, and I'm not even using the command line. Okay, anyways, what happens here, so we're going to go over perfect number generator first. So what happens here imports the math because you need to get square roots here and things, like right there. So what happens here is it imports math because it has to, then defines two different functions. The first one's kind of small, the second one's rather large. Okay, so first we'll start off with the first one. Define perfect numbers. So this one's the one that generally... So this one's the main one that runs this one. So this function will actually be placed inside of this function. So when you put perfect numbers, generate between, also known. So this is a variable. It tells you, it asks what you want to generate perfect numbers up to, and turns that to an integer. If you say something like 0 in words, as in, let me show you, like that, then it's 100% going to say, like, yeah, that is not a number, so it's not going to work. As well as, if you say something that's below 2, it's going to tell you there's an error through the if-else statement. I also put try except in this because it makes it clear about if there's any errors or anything. So if there's a value error, so that integer thing where I showed you if you type 0 it won't work, like 0 as in, or things like that, then it's probably not going to work because that's a value error. It cannot convert chars or a string to an integer. So it's going to say invalid input because there's an exception of a value error, that specific type of exception. So now back to the functions. What happens here is there's a list called perfect nums that is created here for a variable num, which is stated right first here, but should be at least. And then in range 2 to n plus 1, so the number you here plus 1 in that parameter, which right here is this variable, generate between, which integerizes, yeah, you know where it goes. It gets the integer of what you want to generate up to, puts that in there, generates from 2 to that number. It starts from 2 because 1 is not considered as a perfect number. If you're watching this video and you don't know what a perfect number is, I'll tell you. It's a number that's factors, except for itself, add up to itself. So 6. 6 factors are 3, 2, and 1, and 6. Except for 6, there's 3, 2, and 1. 1 plus 2 plus 3 is 6. So it's considered a perfect number. Prime numbers, yeah, you should probably know that. Things like 13, things that don't have factors except for 1 in themselves. So what happens here is perfect nums, it does that this many times in a row, and it's going to find if it's perfect. So this is kind of a brute force method, as it's just finding the attribute for every single number over and over and over again, rather than singling out primes and leaving them behind. I might eventually make a version 3 adding that in. So all that's there. So if it is perfect, so if it's less than 1, it's going to return false. It's just going to be like no. So if this is true, if it returns true, then it's going to do this. If it returns false, it's not going to do that. So, well, it's not going to do that, and it's probably just going to skip and return perfect nums. After that, well, that's after the for loop, for the for num in range loop. So if it's that, it returns false and stops the entire, it stops it from appending that number, and it just keeps cycling through the for loop until it finds the rest of them. And just to state, this takes a bit of like a few milliseconds. And if centi means 1 out of 100, or a centimeter is 100th of a meter. A millimeter is 1,000th of a meter. A millisecond is 1,000th of a second. So if you type in million, it's probably going to take about 10 seconds or up to 100 seconds. It depends on what you do, because this entire program takes a few milliseconds to run, as computers are very fast. I actually think it takes around 300 milliseconds, I think. But whatever you type in, it's going to cycle that many times in this for loop. Well, that many times minus 2 plus 1. So that many times minus 1. Actually, that many times minus 2. So, after that, it's going to find the sum of divisors. Start with 1, as it's always a divisor. Because 0 cannot divide, just leaves the number the same. So does 1. Actually, 0 divided by something divided by 0 is probably going to be the whole number again, or it's 0 if it's otherwise. So square root of number equals integer math square root num. So it's going to take from the math module, take the square root of num. The square root of num is very important, as it's going to use that here. So after that, it's going to check if for I in range. So that's another variable, but that's just a counting variable instead of a num variable. For I in range 2, from 2 to square root num plus 1. So it's going to go from 2 to this number plus 1. So it's going to find the square root of the number that you've entered. And that many times, it's going to go through this. If it's going to go in if statement, if num, what does that mean? Hold on, I searched that up, I forget. I think that means remainder. Yeah, if num, so how many times num goes into I? If the remainder of num divided by I, or I divided by num, one of those is 0, it's going to keep going. Otherwise, it's probably just going to stop there and do that all over again as many times. And I is going to keep changing, as it's going to count in I instead of anything else. So then it's going, if that's true, sum of divisors plus I. So it's going to add I to the sum of divisors. So I plus 1. I can be any number, honestly. It's not an imaginary number because this is code we're talking about. I is a variable, not an imaginary number in complex math and stuff. So after that, there's an if statement. If I is not equal to number, whatever that means. What does that mean? I keep forgetting what I code myself. But if I is not equal to num, what does that mean? I'm gonna check. I need to check. Hold on, give me a second. Floor division. Got it. So it will do that if I divide by num and divided, but it's floor division. So it avoids adding the square root twice. Whoa. Okay, yeah. Never mind. So it avoids adding the square root twice. So it can avoid that, it does this. So after it avoid that, then it does that. Otherwise, it just runs straight to this, which is the end of this function. So sum of divisors plus num, floor division I. I said floor division because it's floor division. I can't turn it to just division otherwise. So then there's a comment, prompt the users to enter a number. So yeah, I've showed you that. It's a try and except script. So try, do that. So it's going to ask you what number you want to generate perfect numbers up to. Then what it's going to do is if generate between is greater than 2, print please enter a number greater than or equal to 2. Else print perfect numbers, generate between. So then there's an accept value error, which I may have showed you. It tells you an invalid input, please enter a valid integer, which means one of those numbers in any combination you want. And yeah, that's basically it. Now we can move on to prime number generators. Okay, yeah, this video is already 13 minutes long. Now we're on prime number generators, but for the sake of the length of the video, I may need to do this in a separate video. So for now, like and subscribe. See you later. Bye. Oh yeah, I almost forgot to tell you. The code for this one is going to be in my GitHub repository soon. After I post this video. Okay, why is this here? So, we're going to go over the prime number generator in another video. Hope you liked this video. See ya.